Right. So we have data, input statement, card statement. Let's say the second cow before the treatment, let's say it's giving 5.2 liter. Then third cow 5.5 liter, sorry, 4.5 liter. Fourth cow 4.8 liter. Fifth cow giving a milk yield of 5.1 liter. Sixth cow 4.4 liter or 6 liter, right? One cow, I will take only few data. So one cow, let's say 4.9 liter. So these are the data taken before giving the hormone. On an average, these are the yield. After giving the hormone, let's say this first cow gave a milk yield of 4.5 liter. Second one gave 5.3 liter. Third one gave 4.5 liter, same amount. The fifth one came, sorry, fourth one came gave 4.8. Next one gave 5.3 as an example. Next one gave 4.8. And the last one gave 5.0. Have you all recorded all the data? Right. Now we can say again properties test. Here, we can do the t-test in two ways. Right. One is property test. Can you remember what did we do theoretically when you have this dependent samples? Anyone? We said there's no any analysis procedure available for dependent sample. So that, what did we do? We made it into independent sample, right? We took the difference. Can you remember the difference? So we can do it in that way. Otherwise, we can, I will say, property test paired, right? Paired before into after run. Sorry, something else happened. Yeah. Is the data correct? 1, 2, 3, 4, 5, 6, 7. Something went wrong. I have removed some set of data. Are you all in? Okay. You submit and see. Before that, what is my null and alternative hypothesis? We can test in two ways. Let's say my null hypothesis mu d equals 0. The difference is equal to 0. Mu d not equal to 0. Actually, what we want to test, anyone? Do you accept this? Or what do you think? This, the second alternative hypothesis. we say we are giving a hormone to induce the or to increase the milk yield. So what is actually my alternative hypothesis? Is it not equal to 0? Is there any point testing whether it is not equal to 0, the mean difference? No comment. Ape aramunamuna may given by this hormone.
Greater than 0.
Yeah, our main aim is to see whether milk yield is increased by giving this hormone. So that what is my null and alternative hypothesis? Null hypothesis fine, mu difference is equal 0. Alternative, mu d should be, let's say if it is before, or for example, after minus before, this value should be, if there's an effect on hormone, if this value should be greater than 0 or less than 0?
Greater than 0.
Greater than 0. Suppose if I have other way, if there's an effect on hormone, what is the results? How we can write relation to 0, in relation to 0? Less than 0. So we'll have to be very careful about these two, huh? Because in both cases, both are correct. Both are relevant to our question. After minus before greater than 0 means there's an effect on hormone. Before minus after less than 0, that is also indicate there's an effect on hormone. So both are correct. So it depends. So we can see this is greater than 0 or less than 0. It depends on how the computer calculates. Let's look at this. Right? Let's look at how the computer run the program, and let's say you run the program and see. Now, after looking at the first table, can you guess what computer has done? Whether it did the before minus after or after minus before. What did computer do? Huh? Yeah.
They have mentioned difference before minus after.
Yeah, that is okay. People have noticed that, right? So this has done before minus after. Why it says before minus after? Can't we change this? Yes, we can. You see, before minus after, as I pointed out earlier, this mean value, mean difference, is become as minus value. Right? Mean difference is become minus value. So it is a bit confusing for you. So that we can take mean difference. Why can't we take mean difference plus? So that should be then after minus before. That should be after minus before. So how we can do that? Go back to the program. You see, we can change this after into before. So here it is the way that we want. We can change this. Now after minus before. You see, earlier it is before minus after. Now it is after minus before. You see, run the program. Something wrong. Running. Can you all hear me?
Yes, sir.
Yes, sir. Right, I have switched off the video. Maybe internet connection, due to poor internet connection, something goes wrong. Yeah. 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 I couldn't hear anything. Yes.
நீங்க run option தவிர
Run
code
run
பண்றத
option.
press பண்ணுங்க.
Sir, put code option. No?
Yeah,
Run.
yeah, no. Have you all written down? Have you all written down? Right. Okay. Right. You see, the difference here is, you see the difference. Now it is after minus before. You see, after minus before. It depends on how we do the programming, right? So if you want, we can give before minus after or after minus before, in whichever the way. Earlier you could have observed here, this was only minus value. Now it is a plus value. That is the only difference, but the rest of the things same. So whether it is before minus after or after minus before doesn't matter. Some of the information, it is about the difference. This is the standard deviation. This is the standard deviation, standard error of the difference. The minimum value of the difference 0, because one value is 0. The difference where it is, one value is 0. For example, here my program is already there. Okay, here where it is 0, you see this is 0, the difference is 0. So that is why the minimum value is 0, the maximum value is 0.2. I think somewhere 0.2 in the difference. So that we could say, right, this is the maximum difference, this is the minimum difference. That's what it says, maximum and minimum. Right? Now, these are some of the information. Mean value, confidence interval of the mean. So the confidence interval, we can say it is in between upper value and the low value. Low value is 0.0587. Upper value is 0.1985. Right? From this itself, we can test the null hypothesis. Why? The mu difference is equal to 0. Does this 0 coming in this range of the value? This is the rejecting region on both sides, right? Rejecting region. I have already taught you in your first course. These are rejecting region. Now it would have been evaporated. I know. This is non-rejecting region, right? So now you see where this 0 value. Is it falling in rejecting region or non-rejecting region? Anyone?
Rejecting region.
A rejecting region. 0 is somewhere there. So we can reject our null hypothesis. So based on this confidence interval, we can make the decision. Right. Now, that is one way. The other way, we can look at this table. So null hypothesis, mu d is equal to 0. Alternative, we can test anything. Mu d not equal 0, but there is no point of testing mu not equal 0. Why? Because we know that by knowing that the milk, once you give the hormone, the milk yield has to either increase or remain same. There's no point of saying the milk yield decreasing, isn't it? There's no point of saying milk is decreasing by giving hormone. Can you say like that? No, no point. Right? So it will work. Random possibility. Under hormone கொடுக்கிறதால milk yield கூடலாம் அல்லது milk yield சமனாக இருக்கும் முதல் போல சமனாக இருக்கும் குறையாது ஹோமோன் கொடுக்கறதால குறையாது. அவரேஜ் மில்க் குறையாது. டோட்டல் அவரேஜ் மில்கில் குறையாது. அப்படி என்ன ஹோமோன்ல வேறு ஒன்றில் கூடும் அல்லது சமனாயிருக்கும். ඒ කියන්නේ දැන් හෝමෝන් දුන්නා නම් එක්කෝ මිල්කිල් වැඩි වෙනවා නැත්නම් වැඩි වෙන්නේ නැහැ. සමාන විදියට තියයි කලින් තියපු විදියට. හෝමෝන් දීපු ගමන් මිල්කිල් එක අඩු වෙයිද? නෑ, එහෙම අඩු වෙන්නේ නැහැ. That is not an experiment. එහෙම අඩු වෙනවා නම් අපිට හෝමෝන් වලින් වැඩක් නැහැ. අඩු වෙයි නැත්නම් වැඩි වෙයි කියලා කඩේ දෙන්නේ නැහැ. கடையில ஹோமோன் விற்கிறது மில்கில் கூட்டும் அல்லது குறைக்கும். For example, broiler feed, broiler nutrition. If you take nutrition, it may increase the body weight, it may decrease the body weight. Do they sell like this? No, they sell it as it will increase the body weight. So likewise, the milk yield will be increased. That is how they advertise, right? So here, because of that, we can go for our alternative hypothesis. Alternative hypothesis, we could say mu d is greater than 0. Here we went for after minus before. So after value is higher than the before. So we could directly say we are testing this. Now look at, this is the table t calculated value. Simply, very high. This is the probability value. What is the p value? Anyone? 0.0041. This is for 2 tail. If it is for 1 tail, we'll have to divide our actual p value is 0.0041 divided by 2. 0.04 divided by 2. Can you remember? We also seen the table, how to look at the t table. We already learned in our first course, right? How to look at the t table. If it is a 1 tail, if it is a 2 tail. If it is a 2 tail, you directly read it. If it is a 1 tail, you multiply by 2 and read it. Can you remember? Similar to here, the probability always given for 2 tail situation, right? Probability is given for 2 tail situation. That is why here it is given as, you see here, already it is indicated p greater than or greater than t. It is 2 tail probability with a 2 tail. That is why you have absolute value. 2 tail means you have plus in this side, minus in this side. So that is why it is giving in an absolute value t, right? If you divide this by 2, that becomes as 0.00 to let's say 21 or whatever it is, closest value, 4 decimals, right? Sorry, 225, right? Sorry, what is the answer? Let's say 21, closest answer, right? 21, the closest answer. So now this is my p value. Now consider my alpha value. It is 0.05. This p value is nothing to do with alpha value. Alpha value is decided by us, right? So now my alpha value is 0.05. Check with alpha value, right? If my alpha value is greater than the p value, doesn't matter it is a 1 tail or 2 tail, then we reject our null hypothesis. So what is my alpha value? 0.05. What is my p value? P value is for 1 tail 0.0021. So that we could reject our null hypothesis. So we could accept our alternative hypothesis. We say that applying or giving hormone will increase the milk yield in cow. It will increase the milk yield in cows. So that is how we do the pair T test. Any questions?
So it is 0.0205.
Yeah, you are right. 0.00.
There's only 1 0. After that, 2.
Is it only 1 0? No. 0 දෙකක් තියෙනවා.
No, 2 0.
0 එකයිද දෙකයිද? මට නම් ඇස්
yes,
පේනවා.
yes, I wrote like that. Sorry, sorry.
මට නම් හොඳට පේනවා ඇස්. තාම. Right. Okay. It doesn't matter. So here, because it is less than the alpha, no. So as long as if it is less than the alpha, no problem. Right. Any questions? So this table always, by default, it is coming as a probability value for 2 tail. It is the probability value for 2 tail. By default, computer gives for 2 tail. If it is for 1 tail, we'll have to divide this by 2 and get the probability value. Make a note of it. For example, for the same example, my mu d null hypothesis is equal 0, alternate mu d greater than 0. Again, let's say I got this p greater than t absolute value. This value is, let's say, 0.063 or 62. Now, what can you say? Because this is, if you say, this is this value for 2 times. Here, our example is dealing with 1 time. So, if you look at, if you directly take, you may end up with it is alpha is less than this p value, so that we don't reject it. Right? Anyone? Any questions? Can you hear me? Can you hear me very quickly?
Yes, sir. Yes, sir.
என்னடா எனக்கு இங்க பவர் ஒருக்கா ட்ராப் பண்ணிட்டு போனது அதுக்கு தாங்க டக்குன்னு. Right. Yes. So if you take this value directly, we may conclude it that we do not reject our null hypothesis. But in reality, you see, actually, it is 1 tail. Actually, it is 1 tail. So that what we will have to do, we'll have to divide this by 2. So that now my probability value is 0.031. Now, what you can say, alpha is greater than the p value. So we reject our null hypothesis. So we'll have to be very careful with playing around with this probability values. So it depends on whether it is 1 tail or 2 tail. Right. Any questions? We can entertain any questions. Any questions? Any questions? No questions. No questions. Yeah. Anuj Kumar.
Yes, sir. I'm hearing.
No. Any questions?
No.
So everybody is perfect now, huh? அப்படியா எல்லாருக்கும் முழங்கிட்டுதா அமெரிக்க நாட்டම තේරුණාද? හොඳ නැද්ද? Yeah?
Yes, sir.
Right. Any questions you can ask? Any clarification you can ask. Right, we will go to the next one. We have seen independent sample. Now we will go for, sorry, we have seen dependent sample. Now we go for independent sample. Data, example 3. I will give any name as I like, right? Input. Let's say I have 2 inputs. This is how we'll have to enter the inputs. Let's take marks. Subject. Subject and marks. I'll put it as subject and marks. Cards. I'm just comparing 2 subject. Right? First subject. Sorry. I'm entering the subject, right? First subject, let's say how 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's take 10 students. Right. See whether 10 numbers are there. Right. First subject. Let's say this is a cramming subject. Not quantitative subject. Let's say you have done biology subject. From 10 of your results, 78 marks, 65, 76, 82, 85. Sorry, you'll have to give a space. I forgot to give a space. You can enter the data and bring it here in the Excel. You can bring, but you'll have to do some other things before bring it here, that I will speak later. Otherwise, the program cannot be run. So 56, 68, 61, 69, 75. So these are the marks. The second subject marks, right? Again, 10 students. Randomly I have taken. The marks are, this is a quantitative subject. 58, one got 86, the other one got 64, the other one got 60, then 43, 48, 61, 49, 53, 58. These are some subjects. Now I want to compare these 2 subjects. Let's say subject 1. So we can name actually with the text, but we don't want. Then we can say proc t-test again. Proc t-test. Class. First time I'm introducing the term, I will say I will explain why it is subject, variable, marks. right? Just a second, in case, right? Here, class, what is class, right? You may not familiar to the, because the rest is same here. T-test, no problem. Variable, that is the variable that we are going to analyze, it is the marks. But here we have additional statement, class. Class means classified variable. How many variables that we have entered? Look at in the input, we have entered subject, that is one variable. The other variable is marks. We have entered two variables, subject and marks. Among these two variables, we will have to specify what is the classified variable. Classified. You see, this the first. Here we say these are classified variable. 1, 1, 1, 1. We have classified grouping variable. What is the grouping variable? So this is the second grouping variable. So the subject are the classified variable. So hereafter we will look at all the classified variable one by one. Right. Any questions? Any questions on programming of two sample full t-test? Any questions? If not, we can continue. Any questions? Is it fine?
Yes, sir.
Right. Tanaumar Madrana Kaikan, Matelaram Vaikala and Sabrilo. Sarasai Busaki item material Volaraka. Right. So we will run the program and see. So this is my output. Right. We can look at different tests. You see, we will come to that. So the variable that we are analyzing is the marks. We are analyzing the variable marks. Subject, first subject, second subject information. How many observations are there for each subject? Then their mean values. 71.5 is the mean value for the first subject. 58 is the mean value for the second subject. Their standard deviation, standard error, minimum, maximum, all these informations were given. Right? The next step is in the same table, we'll have to go for full t-test, not the Sattva-based test. We shouldn't look at the Sattva-based test. We will have to go for full t-test. So the mean difference, this is the mean difference, 1 minus 2. 1 minus 2 means 71.5 minus 58. So that is equal 13.5. That is what it is already given. And the standard deviation, we can calculate the standard deviation in a normal way, pooled standard deviation. And we can calculate the standard error. Not much difference between Sattva-based and the pooled testing. If there's a missing data and ties, there will be a problem. Right. Any questions? Then we will, that is the first table. Let's look at the second table. The second table also the same set of information given. In addition to that, you have this confidence interval. 95% confidence interval for standard deviation, not for our confidence interval. Can you remember the confidence interval for the mean difference? If you have done, right? If you can remember confidence interval for mean difference, not that. But here, this is really confidence interval for mean right? Confident interval for the means. So upper value and the lower value. So this is the confident interval for the mean difference. So if you can look at it, I'm recalling what you have learned in your first course, right? Because we need to talk about that also, the statistics, right? Now my upper value and the lower values are given there. The lower value is 3.49. I will simply write it as 3.49. Upper value 23.51. So this is my upper value and the lower value. So this is the confident interval. So we can say I'm 95% confident. I'm 95% confident that the true mean difference is between true mean difference of the marks is in between 3.49 to 23.51. So the mean difference of these two subjects, subject 1 and 2, is ranging between these two marks. Right? Okay? Right. Now we didn't come to the hypothesis testing yet. That is in the next step. So this is about the confident interval. Any questions? By looking at the confident interval also, we can accept or reject. What is my null hypothesis? Mu1 minus mu2 is equal 0. Can you remember? Alternative, let's say if it is a two-tail, mu1 minus mu2 not equal 0. So look at this, our null hypothesis value, 0. Does this 0 falling in this range? Does this 0 null hypothesis value?
No, sir.
No, it is not falling. Where this 0 falling? 0 is falling in a rejecting region. Since 0 is falling in rejecting region, we can reject our null hypothesis and accept our alternate hypothesis. So this is the decision by looking at the confident interval. We can make that decision, no problem. We can make that decision by looking at the confident interval. Right? So we reject our null hypothesis. Confident interval, it is a two-tail concept, so that we can. Shall I erase this? Have you all taken down? So we'll have to explain the confident interval and explain the results also. I haven't explained the results yet. Hypothesis point estimation. I didn't explain the point estimation. This is about the confident interval. We'll have to tell whether I can erase the blackboard. Only the material that I have written. Yeah. If you don't answer, I will just keep it as it is. I think I will think that you are still writing. Tarchaga. Tarchaga, are you there? Tarchaga. One 1088.
Yes, sir.
விளங்கிட்டுதா?
sir.
Pilini? Serunada?
Yes, sir. Yes, sir.
Right. We will discuss the next table. The third table. That is also important table. Third and the fourth table. Right. Most important is the third table. Right. Can you remember fourth table? Can you guess what is about the fourth table? We learned this. Anyone? Anyone?
No one. F is 0.
Yeah. What is that? Yes, Vaishnavi, what is that? Fourth table.
ANOVA.
Oh, not really, ANOVA. Look at this. Look at your notes, first year notes or 3-1 notes. Can you remember we test one assumption? What is that assumption that we have tested? If you can remember. What is the assumption that we have tested? Can you remember this? Still, we are talking about pool t-test, huh? Independent two-sample t-test. Can you remember this? Have you seen a homogeneity of variance? We said we can test sigma 1 square is equal sigma 2 square. We can test that. Alternative, sigma 1 square not equal sigma 2 square. So this is another testing. Why? Because this pool t-test is valid when you have a homogeneity of variance. Right? When you have homogeneity of variance, only pool t-test is valid. So here, we test that. So you can see the F value. Can you remember F value that we calculated by S1 square divided by S2 square? If you can look at your notes. You could have learned your notes yesterday since I started with this. You could have go back and looked at your notes, which was written in 3-1, right? So this is the testing. So F calculated value, that is your F calculated value. And this is the probability, exact probability. So here, the alpha value is much lower than the probability value, so that we do not reject our null hypothesis. So that is my conclusion. Do not reject my null hypothesis. So in other terms, we accept our null hypothesis. If you accept our null hypothesis, so we can assume that there is a existence of homogeneity of variance. So we could say our pool t-test is valid. So we can continue with our pool t-test, reading or expression or explaining or concluding. Our pool t-test would be still valid because we are rejecting our null hypothesis here, homogeneity of variance. Right? I will erase so that based on that, we accept our homogeneity of variance so that we can look at this information. We can look at that information. That is about the pooled t-test. So we want to look at the pooled t-test, assuming that equal variance. If there's not equal variance, then we cannot look at this pooled variance. We'll have to look at Sutherland's test, right? So here our variance is equal, so that we can look at this line, right? Degrees of freedom. This is the pool degrees of freedom. This is the table value. This is the probability value. I will erase it. I will write the probability value there. So what is the value? 0.0110. This is for two type. This is for two type. Right? Now let's say my null hypothesis mu1 minus mu2 equals 0. Mu1 minus mu2 not equal 0. So I said the subject 1 is a biology subject. Subject 2, it is mathematics. Normally, in your class, which subject was easier, mathematics or biology? Actually, biology was easier compared to mathematics. So usually, but mathematics is much, in reality, mathematics is much easier. If you understand the concept, it is easier. If you don't understand, forever you will never understand. Some people don't want to understand even after graduating. So that is a different story. So here, the average score, if you look at here, you see the average score for biology is 71.5. The average score for the mathematics is lower, much lower than the biology. So now you see mu1 minus mu2 is equal 0. That means no difference between the mean score of biology and the mathematics. If this is not equal to 0, that means one of the subject is having poor performance compared to the other subject, or one of the subject is performing better than the other subject. We don't know what is the subject. Right. Now, if you test it, this concept, our p-value is this. So that we could say our p-value is much lower than the alpha value. Therefore, we reject our null hypothesis. So that means there's a significant difference on marks, on average marks. There's a significant difference on average marks between subject 1 and subject 2. That is how we write. There's a significant difference on average marks between subject 1 and subject 2. This is how we report. For example, if my condition, because I am starting with a null like this, alternate, we know that mu1 representing biology subject, mu1 minus mu2 greater than 0. This is a one-tail situation. Earlier one is a two-tail situation, one-tail. That also we can test it. So here we want to see whether on an average, biology marks is higher than the mathematics marks. Biology marks is higher than the mathematics. For that, again, we take the p-value. Now, the same p-value, 0, 1, 1, 0. Now we cannot take this p-value as it is. Why? It is a two-tailed p-value. Now we'll have to take it for one tail. If it is one tail, we'll have to divide by 2, which is 0.055. Let's say 0.0055. This is for one tail. One tail situation. Now we compare this with our alpha. Alpha doesn't change. Always the alpha is same. So still our p-value is much less than the alpha value. So we can reject our null hypothesis. So what is our conclusion is, we could say on an average, the biology, average marks on biology, on an average, the average marks on biology is significantly higher than the average marks of mathematics. Average marks on biology is significantly higher than the average marks of mathematics. Right? Is it clear? That is how we can report. So the reporting is based on how you formulate your null and the alternative. Null usually as it is, but it's depend on the alternative hypothesis. Any questions? Any questions? Any questions? Anyone? Can you all hear me? Are you all there?
Yes, sir.
Okay, good. Any questions? Bhagya,
Yes, sir.
any questions? Monali Prasna Tina?
No, sir, understood.
Understood. Nilum?
Yes, sir.
Yeah. How about you? Did you understand? Mohammed
Yes,
Tappe?
Understood, sir.
Okay. Sahana,
Yes,
Jayarasa. Yes. What is your situation? Huh?
I understand, sir.
Okay, you understood. Okay. Any questions? Rania,
Yes, sir.
any questions? ஏதாவது தெரியாது பிரச்சனைகள்?
No.
So that is good. Everybody understood mean that is good. So everybody should know. So basically, two things that we'll have to remember, or three things. First thing is, you should know how to enter the data. In each cases, the way that we enter the data may differ. So we'll have to remember entering data. Second thing, the program, the lower part of the program that you are writing, that should be very clear. If it is one sample t-test, how you do it. If it is a pool t-test, how you do it. If it is a paired t-test, how you do it. So that is the second important thing that you should remember. Third one, you should be able to interpret the results. Computer will never interpret for you. You will have to interpret by yourself. Right? So here, the output of the present. I mean, the program has to be correct, and the interpretation. Interpretation will get almost 2/3 of the marks. Then the program. If you write the program correctly only, you will get the correct output. Otherwise, you will get some output. Right? You will get some output. But you should be able to interpret the output. Right? Okay. So everybody understood? Good. Now we will look at what are the lower part will give normally. Here, in addition, in old SAS, it doesn't give, but in a new SAS, it gives some additional information. You see, this is for subject 1. This is for subject 2, for both subject 1 and 2. You see here, subject 1, subject 2. How the data are distributed. The distribution of marks for these two subjects. So this is subject, first one is for subject 1, second one is for subject 2. Just to give some ideas. We may use this for ANOVA later on. For here, we are comparing only 2 marks, so that it is not very important as such. Look at here. What is this? Values. You see, these values, if you could see, I can show, you can realize what are those values. Right? So you could see it has a relation with this table. So it has a relation with this table. Actually, some parts also there in this table. That is, it's given the mean plus or minus standard deviation. Or sometimes it gives with the standard error values, right? So here it is giving, look at it, what is the mean value? 58 plus or minus standard deviation 11. So that is 48, something like that. 48 and plus, this is the mean value, right? So it is indicating the mean value. You see, this is the mean value. Mean value in both cases. One mean value is some 58 or something, right? This is 71.5 or something, mean value. So that middle point is mean value. Can you remember mean plus or minus standard error values? Right, standard error with the table value, so that that value is already there. So 58 plus or minus and 71.5 plus or minus. You could figure it out, the values. Just a second, here we don't have the complete value as it is. 58, 49, 50, not confident, either not confident interval also, right? Not confident interval, just a minute. Yeah, this is basically, you could say it is the range of values that it covers, right? This is called as QQ plot. This sometimes people who are very poor in statistics, they use this QQ plot always and say normally QQ plot. This is for subject first subject, right? Let's look at only for the first subject. You can interpret the second subject also. So how each points, for example, this is your observed value, right? How it is deviating from the predicted value. So this is observed value. Predicted values are the values that is on the line. So how far it is deviating. For example, if you have a QQ plot like this, that is a good set of data, right? If you have another set, this is not a good set of data, all right? So this is a good one, good set of data. If just to see how the data are deviating. For example, subject 2, you see some of the data are not really good data, they are deviating from the mean value, I might, right? So that is how we can interpret that. So you don't need a QQ plot, but just an example. Yes. Any questions? So you can also save. We'll save it as 3. So next time if you want, we can get it. Right. Any questions? We can do some regression analysis. So data, if you have a set of data, we can use it. Example 4. Let's say input. In regression, what are the types of variables that we have? We learned the simple linear regression. What are the types of variables that we have? Anyone? What are the types of variable? What type of variable do we have in simple linear regression? Sabiba? Sabiba, are you there?
Yes, sir.
Yes. How many variables do we have in a simple linear regression? We learned this in our first course. Today, up to today, we will talk about all the analysis on the first course. Then only it is a foundation for the next step. Sabiba, you can tell, no problem. What are the variables? Yeah.
Two, independent and independent.
Very good, very good. What are those? How do we demarcate? How do you name those variables? Dependent, symbolically. Dependent, Y variable. Independent,
Variable.
X variable. Good. So that we could say, I'm going to enter only 2 variables, X and Y. That's enough. right? I will say X and Y. So I will take some example. Give an example. Let's say rubber. Rubber tree. Yeah? In rubber tree, ultimate product is latex, right? So this latex, amount of latex is depend on the diameter of the tree. Do you agree with that? Amount of latex is depend on diameter of the tree. If the diameter is higher, latex is higher. If the diameter is small, the latex is low. Right? So X in my case, it is diameter of the tree, rubber tree. Y is the latex yield. Right? I cannot write diameter and latex yield here because it is becoming larger and larger. So I will put it as X and Y. So our interpretation is going to be based on this diameter and the latex. Right? So I'm going to enter some data. Diameter in centimeter, make a note of it. Yield is in kilogram. Rubber yield is in kilogram. So first tree is 23 centimeter, yield is in kilogram. So 1.5 kilogram at 1 day or 2 days, 1 point or 2.5 kilogram. I don't know what is the average rubber yield. Anyone? What is the average rubber yield? How many of you are doing agronomy? Raise your hands. I want to see agronomy people. Raise your hands. Who are the people doing agronomy? Okay. Only one, two. Only two. No, only four. Only four. Right. Only four, huh? Agronomy people, yeah, Kirija, Nelum, Krisha, and Jayatis. Yes. Now people are coming, right? 1073, I don't know the name. Subaraj, Jayatis. Yes, good. So what is the rubber yield? I'm asking from those group. What is the rubber yield, average rubber yield in one panel? What is the rubber yield in one panel? Anyone? Just for my information, just for our analysis, nothing else. Yeah.
Normally, sir, 800 to 1000 kilogram per hectare per annum.
So how many? 800 to 1500 kilogram per hectare per annum. So what is the plant density per hectare? What is the plant density? How many trees are there? Anybody from Kalsara area? There may be a lot of people from Kalsara area. Kalsara, Piliyandala, Kasbava. Those areas you can see lots of Matugama, rubber. Yeah, I don't know. Doesn't matter. We will have some value because whenever we learn, we'll have to learn with some actual value. I cannot simply say paddy yield 20 metric ton per hectare. Can I say? I mean, that is not logical, isn't it? So we'll have to study with some logical values. So then only it is good. Right, now I have first tree, the yield is 2.5 kilogram, right? Second yield 34, it is giving a yield 3.6 kilogram. Fourth one, 30, giving 3.2, right? 27, giving a yield for 2.8. Then 26, giving a yield point 2.6. 32, giving a yield point 3.3. As an example, I'm just cooking the data. 36 centimeter diameter, getting 3.6. 38, 3.7. Right, big tree, let's say 40 centimeter. Normally we don't get, but 3.8. Right, now this is my data. I want to do a regression analysis. Can you remember regression analysis? So regression analysis, here we have X variable, here we have Y variable. This is a positive correlation, a positive linear relationship, or we call it as direct linear linear relationship. Then we can fit a line. Then we can predict the value of a given X value. So that is the main purpose of this regression line. Right? Give me a second so that we'll get some water. Right. So now we want to perform the regression. Could you remember we talked about regression and correlation, then R square coefficient of determinant. All we can try using this. Right. Now this is my data. Can you all hear me?
Yes, sir.
Yes, sir.
Yeah, right. Proc. This is the procedure for regression. We simply say rig, REG. That is more than enough. We don't need to say regression, proc regression. Then you see here we have two variables. Can you remember? First time we are going to talk about how do you call this? Have you seen something like this?
Simple linear regression model.
Simple linear regression?
Model.
Yeah, model. This is model. So this is the model for the simple linear regression, right? So here you want to relate this variable. These are the two variables that we will have to indicate, right? These are the two variables that we will have to indicate. Computer automatically calculates these values. So that what I'm going to do is, I'm going to type model. Tell me how I can type in the model, which equal what? Y equal X here. The rest is automatically calculated by the computer. Right? The rest is beta naught, beta 1, and the error term will be calculated automatically by the computer. So that model is equal, model Y is equal X. Then run simple. Right, submit the program and see. Sorry. Submit the program and see. So you are getting a box. You see the model dependent variable. Can you remember? Because Y is equal X, not X equal Y. So automatically it will identify Y as the dependent variable. Right? So number of observation, number of missing observation, those are all observations are there. We don't have any problem. This is the ANOVA, analysis of variance, ANOVA. Now you are expert on ANOVA. You see source of variance, degrees of freedom, sums of square, mean square, F value, and the probability. Probability of F distribution. Earlier, probability of T distribution. Here, the probability of F distribution. So, model mean, here this is a regression. Because here we are doing a simple linear regression so that we can, we have only one X variable. Here, we have only one X variable. Suppose if you are doing regression with several variables, I'll take very simple one. Right? Now here, we have several variables. What are those variables? Dependent variable. There are two independent variables. So 3 variables are there. So that is why it is giving as a model. In this case, it will give as a model, source of variance, which indicate our X1 and X2. But in our case, here we don't have other than X variable as the independent variable. So that we could say regression is the model. Then we have error, then we have total, corrected total. So degrees of freedom, n-1 for the total. 1 is the degrees of freedom for regression. n-2 is the degrees of freedom for error term. They are sums of square. I don't want to describe how calculated. Everybody knows how to calculate the sums of square manually. So here it has calculated. Now we have the mean square. This is the ratio between the mean square of F calculated value is the mean square of regression. I'm not saying anything other than what we have learned in our previous course. Mean square of error. So here you have the values 1.85 something divided by 0.01285. This value is given there, 144, oh, very high, 144 something, our F calculated value. This is the probability. This is the probability. P-value is usually 0.0001. Less than that, we can take it as probability 0.0001. 30 and 1. Before we make the decision making, what is my null and the alternative hypothesis? If you can remember, what is my null and the alternative hypothesis? Anyone?
There's a significant relationship between X and Y.
Partly correct. There's a, what is null hypothesis? Your statement is partially valid for alternative hypothesis. What is null hypothesis?
No significance between.
Between what? So do you have notes? If you have notes, then just go through.
Diameter and the latex period.
Yeah. Whatever you said significant and so on, we accept, but let you tell what we are testing. Do you have notes with you? Have a look what we are testing. We did them manually also in our previous course. Anyone?
Beta 1 equals 0.
Good. Tell me.
Null hypothesis beta 1 is equal 0.
Very good.
Alternative beta 1 not equal 0.
Okay. Yes. Good. What do you mean by this? What do you mean by beta 1 is whoever said? I couldn't trace out who said it, but yeah, it is correct. This is correct. Perfect. No problem. What do you mean by beta 1 is equal 0? How we can say? We'll have to tell everything in the words. If I go and tell farmer beta 1 is 0, beta 1 is not equal 0, farmer doesn't understand, no? So farmer, even our non-statistician will not understand. So how we can say this? Person who tried this beta 1 is equal 0 and beta 1 not equal 0 can tell. You can put it in within the
There
bracket.
is a no linear relationship between.
Right, good. So there is no linear relationship. Once we give the conclusion, we will add what are these X and Y variable. For the short in form, there's no linear relationship. When beta 1 is equal or not equal 0, there is a linear relationship. Very good. Let us, even after trying, yes, good. The answer is good. So now we are testing whether there's a linear relationship or whether there is no linear relationship. This is what we are testing. Right, now our p-value is, as we said, very low, 0.0001, and alpha value is, suppose, let's say 0.05. Definitely p-value is much less than the alpha value. we can reject our null hypothesis. So we accept our alternative hypothesis. Now, how we make the conclusion? Now we can include what I said in the question. What is that? What I said in the question? X is diameter, Y is E. How we can conclude? There is a, yes, go ahead.
There is a linear relationship between the latex and the diameter of the rubber.
Yes, there's a linear relationship between the latex and the diameter. You can write in the words, diameter of rubber trees. Right? There's a linear relationship between latex and diameter of rubber trees. Fine. Everybody knows. Once you say there's a linear relationship, everybody understands. No problem. Right? Right. Now, we said we have concluded that first thing. We need, can you remember what is our, we want to estimate beta naught and beta 1. Right? What is our beta naught and beta 1 hat? So that we can identify from here. It says intercept. That is this value, 0.58075. The parameter estimates of x variable is beta 1, which is 0.08347. So we can write down the equation as 0.58075 plus 0.08347 x. So this is my predicted equation. This is my predicted equation. Is that clear to everyone? So in last semester, we calculated everything manually. So now automatically it comes. Once you enter the data, it comes. Pop up. And the other thing is here, whether these parameters, beta naught and beta 1, this is about the beta naught, and this is about beta 1, whether they are significant or not. Actually, we don't need to look at in this simple linear regression concept. Anyhow, beta 1 is significant here, which we have already seen there. Right? Right. Two more things important here. Shall I erase this? Sivadiyakaran?
Yes, sir.
Alikatiyada?
Deleted.
Right. Okay. If no one is answering, I'll have to ask a particular person. If that person is okay, then I will erase. Right. Two things we want to learn here. Right. Automatically, it gives coefficient of variation. This is what we learned in our first course, CV, coefficient of variation. That is how we get the coefficient of variation. S divided by x bar into, so here it is percentage, right? X divided by S divided by x bar, where it is S, standard deviation. You don't get it, yeah. Right? So this is given by the CV. That is fine. Right? We need two other things. One is R, the R square. In regression, these are the two things. Right? So here, R square is already there. What is the R square? Here the R square. This is what we will have to look at it. We don't want to go for adjusted R square. We can say R square. That is almost in 2 decimals, 0.95. Very high. 0. This is R square. R square, right? R square, not R. R will have to get it in a different way. I will show it. This is R square. So can you remember what R square says? This is the total variability. If it is in a percentage, this is 95%. So how we can explain this R square? Among the total variability of latex yield, among the total variability of latex yield, diameter of the tree explaining, actually this is from our previous course. Sidamara Sakarata Pevatamari Irkame. This is from our previous course. That is why I am directly writing it. කොහෙද යන්නේ මල්ලපොල් වගේ නැතුව මේක අපි පළවෙනි course එකේ ඉගෙන ගත්තේව තමයි අද කියන්නේ. Right? So among the total variability in latex yield, diameter of the tree explaining almost 95% of the variability. % of the variability. Okay. Among the total variability of the latex yield, diameter of the tree explaining almost 95% of the variability. So that is how we can explain this R square. Is it clear? Right. Now, if you take the square root of this, then we can get the R, but we should have some program. We should know the program how to get this R value. So we will go for that program. R is not there, so we will go for that. Any questions from here? To get the R, to get the R, we'll have to write a different program. It says clock correlation. Right? Prox correlation variable X and Y. So this is how we give the command. Proc correlation We don't need to write because SAS identify even 4 letters, right? Of correlation. Or variable X and Y. Can you all see the slide?
Yes, sir.
Right.
Yes.
Okay. I will press. Now you see, we have the correlation. This correlation actually, if you have several variables, it will give a correlation matrix. So the 2 variable, the individual variables details are there that we don't want. If you want, you can have a look. It is the information about individual variables. But the most important is this one. So look at this table. So in this table, this is called as correlation matrix. You have learned matrix, right? Correlation matrix with the arrays, right? Correlation matrix. So how X correlated, that is perfect correlation 1. How Y and Y correlated, that is perfect correlation 1. So this correlation, either this and this are same, because this is Y versus X, this is X versus Y. Both are same answer. You can look at only one answer. So 2 information is there. Look at the first information. First information gives the value 0.97661. Normally, when you write in a report, you have to write it like this. 2 decimal is enough. Sometimes people are calculating for 5 decimal, 6 decimal. 2 decimal for R or an R square is enough. Get the closest decimal. So this is, I can write it as 0.98. Can you remember what is the possible range of value of R? Anyone? What is the range of value possible in any data? Yes. Range of possible values? No one? What is the range of possible values of R? Hear me? Vidusan,
Sir,
what is the range, possible range of value of R? Hmm?
0 to 1, sir.
0 to 1. Madhusha Pushparaja.
Sir,
Yeah. What are the possible values or the range of possible values for R? 0 to 1 is one possibility. What is the other possibility? He has missed out one part.
-1, 2 plus 1.
That is, you have missed. Now only you have seen the notes. Good. At least you can choose that in notes. Natang malakada kai notes ticket. So the R value can range between +1 to -1, which I have given in my notes. I have given the PDF notes. So R value. So this minus and plus indicating how the direction of the relationship is. Whether it is having a positive relationship or whether it is having a negative relationship, that based on this plus or minus concept, right? Right, now anyhow in this case it is a positive relationship. That means the R value is very positive, so it is a direct relationship, and also the R is very, very high, much closer to 1, so very strong relationship. How do you say this R? What is the name of this R? Anyone?
Correlation coefficient.
Right, correlation coefficient. By definition, how we can say what it measures?
The strength between
Exactly, strength of the relationship between these two variables. Strength of the relationship. So this is R. So that is the first point. The second point, you see, automatically it is giving a testing, hypothesis testing. So you see here probability for the hypothesis testing. So null hypothesis, you could see here where the R is equal to 0. All right, R null hypothesis is equal to 0. So that means there's no relation, closer to 0. And alternative are not equal to 0. So it's testing. So you see the probability value is very, very, very low compared to alpha value, so that there's a significant difference where the R is not equal to 0. So the correlation is very strength, very high correlation. Look at here. I will just erase it. Here, the p-value, that is for the R, the p-value is 0.0001, even less than that. Now, in another case, for R, I have a p-value, let's say 0.0455, something like this. Now, here the p-value is very low. Here the p-value is closer to alpha. So by looking at these two, here also significant, this is also significant, because if you take the alpha value as 0.05, this value also less than alpha value. This value also less than the alpha value, so that this is also significant. But there's a level of significance. Here we can say high significant. Here we can say only significant, marginal significant, because it is much closer to the alpha value. You see? So whenever the p-value goes smaller, 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 the significance, the relative significance changes. Significance become quite high, right? Okay, you can learn more and more, because any questions? Any questions? Any questions? If not, we will wind up and meet tomorrow morning. Tomorrow we will start with the ANOVA, which we have learned really, because you need to know about the all statistical approach, right? So that is why I have given all the opportunity to learn from the other